Strap in, everyone. Today we're going deep, really deep, into a question that's got the AI world buzzing. Can a machine learning model, can it actually know how well it's doing? Like, can we figure out its accuracy before we even see the results?
Yeah, it's a question that really gets to the core of how we understand and evaluate AI. And what's so fascinating is it's not just about, some vague idea of self-awareness. It's about building a solid mathematical way to predict a model's own errors.
And that brings us to this paper. When does a predictor know its own loss? It's like, whoa, the title itself is a brain twister.
Yeah, it kind of has a philosophical vibe, doesn't it? But the implications are really down to earth, very practical. We're talking about potentially changing, like revolutionizing how we look at AI systems, especially in areas where the stakes are high, like medical diagnoses or lending money.
So let's break this down. The paper zeroes in on binary classification. Those AI models that give a simple yes or no. But the idea is they spread way wider, right?
Absolutely. To get how it works, we got to start with the loss function. Basically, it's a way to measure how wrong a model is. Bigger the error, higher the loss.
Okay, makes sense. We've got these AI models making predictions, and we use this loss function to see how far off they are. But how do we predict that loss before we know the real answer?
That is the big question, isn't it? The paper, it dives deep into this. It explores this idea of like building a separate AI model, a loss predictor. And this thing, it can estimate the loss of the original model, kind of like an AI watchdog, always watching, evaluating how the other one's performing.
I like that, the watchdog idea, but how do we even start to build something like that?
Well, there's a natural place to begin. It's called the self-entropy predictor. So every AI model, just by existing, it makes assumptions about the world. These assumptions, they show up in the probabilities it gives to different outcomes. Like a model might say, I'm 80% sure this is a picture of a cat.
So it's like the model has its own internal beliefs, like it's saying, this is how likely I think things are.
Right, exactly. And the self-entropy predictor uses those probabilities to estimate the model's own loss. Basically, it's like the model is saying, based on what I think is true, this is how wrong I expect to be.
Okay, starting to click a bit now. But is it enough to just rely on the model's own self-assessment? Or can we create loss predictors that are even, like, smarter?
That's where things get really cool. The researchers, they introduced this hierarchy of loss predictors, each level more sophisticated than the last.
Ooh, a hierarchy. Love a good hierarchy. Lay it on me.
All right, at the bottom, you got your prediction-only loss predictor. This one just uses the model's output probability. Then we go up a level, we get to input-aware predictors. These, they get to see the raw data that's fed into the model, like, say, patient info in a medical system.
So more info equals potentially better loss prediction. Got it.
Precisely. And at the peak of this hierarchy, we have the heavy hitters representation aware loss predictors. These can tap into the model's inner workings, like looking right into the model's brain, or even they can bring in outside knowledge from, human experts or other AI systems.
Wow, so different levels of access, like peeking behind the curtain of the AI's thinking. This hierarchy makes sense, but I'm still kind of wondering how it all connects back to that idea of AI fairness we talked about earlier.
Right, right. So that's where multiple regression comes in. Imagine a model that's consistently more wrong for certain groups, like misdiagnosing people of a certain background at a higher rate. That's a multi-regression problem. Basically, unfairness baked right into the AI.
That's a serious issue. So these loss predictors can help us spot that.
You got it. The research, it shows a really important link. If you can build a loss predictor that's way better than the self-entropy predictor, it's a strong sign that the original model has a multi-colligation problem. Like it's like the loss predictor is blowing the whistle saying, hey, something's off here, this model's biased.
So trying to predict a model's errors, it's actually about uncovering deeper problems with how it sees the world, the biases it might have. That's pretty deep. But is it always possible to build these super smart loss predictors?
Not always easy, no. The researchers, they found these tricky things, calibration blind spots. It's where a model might be making consistent mistakes, but the self-entropy predictor, it just doesn't catch them.
So the model's fooling itself and a loss predictor.
In a way, yeah. The research, it gets into the math of these blind spots, showing how a model can seem fine on the surface, well calibrated, but underneath, there's hidden bias.
Okay, got to take a breath here. We've gone from self-aware AIs to hierarchies of predictors to these blind spots. But I like how we balance these ideas with like real world stuff. So Where does all this lead us, practically speaking?
That's the question, isn't it? And that's what we're going to dig into next. We'll look at how the researchers tested these ideas on real data sets with all kinds of AI models and the surprising connections they found. So, about those real world tests, they used data sets like credit default and bank marketing. We're talking AI making decisions about, loans, who gets targeted with ads.
Okay, yeah, that's getting into some serious territory, especially thinking about the potential for bias there.
No doubt. And they really wanted to test these theories. So they didn't just use one type of AI model. They used like a bunch of different algorithms from simple decision trees to those super complex neural networks, the ones everyone's talking about.
Covering the whole AI spectrum. So what happened? Did it work? Did the theory actually hold up when they put it to the test?
The results were really clear. They found this direct connection. The more a model had that multicalibration problem, meaning the more biased it was, the bigger the advantage was for the loss predictor compared to that simple self-entropy one.
So it's like the loss predictor saying, hold up, this model is mixing up way more over here with this certain group. Something ain't right.
Exactly. Yeah. It's like an early warning system flagging that potential bias, before it goes unnoticed.
This is where I really see the power of this. Like, imagine you're a doctor and you're using an AI tool to help you diagnose patients. Wouldn't you want to know if that AI is more likely to be wrong for certain people?
Absolutely. That's what loss prediction can do. It's not just about, overall accuracy. It's about understanding where it's most likely to fail and for whom.
Like a magnifying glass, zeroing in on those areas where the AI might be biased or unfair. This feels like huge, not just for us, the people using AI, but for the people building it too.
Yeah, for sure. This research is a wake-up call for those developers. It's saying building better loss predictors, it's not just some technical thing, it's a crucial step to make AI fairer, more reliable, something we can all actually trust.
And isn't that the goal? AI that we can count on to make decisions, big decisions without perpetuating those biases or even worse, creating new ones. But I mean, if we can predict where AI is going to fail, doesn't that open up a whole other can of worms?
Oh, definitely. If we can design AI that's like aware of its limits, always double checking itself, you know what I mean? How would that change how we interact with these systems? Would we trust them more? Would we use them differently?
Like AI is growing up, becoming more responsible, but where do we go from here? What's next in this whole field of research? Feels like we're like on the edge of this whole new AI world where these systems aren't just predicting stuff. They're like understanding, communicating their own limits.
It's a pretty wild frontier, right? And this research we've been talking about, it's really just the beginning. So much more to explore.
Like what? What's got you excited? What's next for research?
Well, one thing that's really promising, it's developing those loss predictors even further, making them even smarter. Maybe bring in some ideas from causal inference. Oh, hey, welcome. What's up?
Sorry to interrupt. So what's the super derivative in the loss predictor?
Oh, you mean superderivative. So the lemma defines it as the HO.
Yeah, it's a technical term, but what it means is that blind spots can occur.
Exactly. These blind spots are those points where HO equals 0,
And that means the loss becomes independent of the label.
making loss prediction trivial in those areas. Does that make sense?
Okay, now that we cleared that up.
Yeah, so getting back to it, one thing that's really promising, it's developing those loss predictors even further, making them even smarter.
Right, right. How do we actually put these loss predictors to work in different fields?
Imagine doctors, they're using AI for diagnoses, but the system also flags cases where it's not so sure. It's like, hey, maybe get a second opinion here.
Or loan officers, they get an alert if the AI's risk assessment seems, I don't know, a little iffy for certain applicants. So they actually look closer at the situation, not just blindly trusting the algorithm.
Exactly. We're moving away from this idea that AI is like this perfect oracle. It's more about working together, humans and machines, using each other's strengths.
Like AI is becoming less of a dictator, more of a trusted advisor, giving its advice, but also admitting when it might be wrong, especially when H equals 0.
Right. And that humility, knowing its own limits, maybe that's the key to AI reaching its potential. Not replacing human judgment, but making it better.
This has been quite a journey from like loss functions to blind spots to wow, the future of AI. I'm feeling, I don't know, excited, but also like cautious.
Yeah, I think that's a good place to be ambitious about what AI can do, but also aware of, the potential dangers.
Well said. And for you listening, we hope this deep dive gave you some new insights, maybe sparked some curiosity.
Next time you see an AI making decisions that affect you, loans, medical stuff, even those social media algorithms, remember what we talked about. Ask questions, demand transparency, push for AI that's not just powerful, but fair, reliable, something that actually benefits all of us.
That's a great call to action. We've covered a lot, including what superderivatives are. But this conversation about loss prediction, multi-calibration, responsible AI, it's just getting started.
And we're excited to keep going to explore it more with you in future episodes. So keep sending in those research papers. We love diving deep with you.
Until next time, keep exploring, keep learning, and keep questioning the world. This is The Deep Dive, signing off.